So let's see what is cyclomatic complexity. So basically, if we see about the cyclomatic complexity, so cyclomatic complexity refers to the number of nested conditions, for loop, while loop, do while loop, if else, switch condition in our code. And if we are going to see this cyclomatic complexity, so it is denoted by a number. And let's see, if there is a function who is doing some particular work, and we are going to convert that function into the flow chart, and again that flow chart is converted to the flow graph. So each graph node is denoted by n, and if each node connectivity line is denoted by h, e, and p is over here point of exit. So basically we can calculate this cyclomatic complexity with this formula E minus n plus 2 into p. So let's understand this particular thing by an example. So over here, some, we can say, statements are there, some logical condition, if else, if this condition is true, then do this, if it is false, then do this, then again some statements, then while loop, do while loop, and we are going to do some calculations, some statements, then again a statement, and this particular function is done. And if we are going to convert this function into a flow graph, so statements are here, then logical condition, if else, if condition true, if false, then come to the conclusion, and then do some work, then again a while loop, if this condition is true, then do this up to this time, then again done. And its function or its particular method is returning the value. And if we are going to convert this, so each box, we can say, denoted by a node. So here we are having the 1 2 3 4 5 6 7 8 nodes, and these are the edge connecting to the node 1 2 3 4 5 6 7 8 9 and 10. And here you can say the exit function. So this is the p. So let's come to the formula. The cyclomatic complexity can be uh, gain by this particular formula, e minus n plus 2 into p. So let's put the value in the function. So e is 10, n is 8, plus 2 into p. So its complexity is 4. So this is how we calculate the cyclomatic complexity. And let's see how much this complexity mean to the developer. So if the cyclomatic complexity of a function is lie between 1 to 10, that means your code is very well written, highly testable, and it require very less effort and cost. And if it is lie between 10 to 20, then means code is little bit complex, easily testable, and it's very uh, normal in terms of effort. And if we come to the cyclomatic complexity 20 to 40, it's very complex code, low testable, high cost and effort. If the complexity is greater than 40, that means highly complexable code, means lots of bugs and error may occur in this particular function. It will require more time to test, and it is very much complex to debug this particular code. So next topic is cognitive complexity. So what is cognitive complexity? So as I already told you, it's basically refers to the readability of the code. So basically it's the mental effort through required to understand the process of information. Means if there is a function is written, and what effort is required by the dev to understand this piece of code whichever is written in that particular function. And if the function is high cognitive complexity, it require more effort in terms of understanding, in terms of doing some changes over there. If it is very less complex, then means it is require very less effort. So let's see how to measure our code complexity. So there are many tools, but over here we are referring these three tools. SonarQube, so it's come as a platform where you can find the code complexity, code smell, code, what are the bugs are there detected by the platform. And if you are using this IntelliJ and Android Studio, then SonarLint comes as a plugin. And for IntelliJ and Android Studio, again we are having this code metrics plugin, code MR plugin. By integrating these plugin, you can check your code complexity.